Okay, at equilibrium, the concentration of this system was found to be nitrogen and oxygen were equal, 0.2, and NO equal to 0.4. If more of NO is added, bringing the concentration of NO to 0.7, what will the final concentration of NO be? So first we need to figure out what the equilibrium concentration or equilibrium constant is. So the formula for equilibrium constant is K equals NO squared divided by the concentrations of N times the concentration of O. There's 2 here. So we're given the equilibrium concentrations 0.4 squared, 0.2 times 0.2, that equals 0.16 divided by 0.4, and that equals 4. Okay, that's 0.04. So, if we're going to change the concentration of NO, we need to set up an ice table. So we have nitrogen, oxygen, and NO, and the initial concentrations are what we started with at equilibrium, except for the NO. So that's 0.2, 0.2, and we're told NO is going to get up to 0.7. So the question is, how much did everything change? Well, we know that it's a 1 to 1 to 2 stoichiometric ratio. So we're going to gain x, we're going to lose negative 2x. Now, how do I know we're going to lose negative 2x? Because we went from a 0.4 to a 0.7 concentration of NO. That means the NO increased, okay? And Le Chatelier's principle says if we make a disturbance, we need to equalize or reach equilibrium again. So when we add products, we're going to shift towards the reactants. Okay? So this is supposed to be change, and at equilibrium, this is going to be 0.2 plus x, 0.2 plus x, and 0.7 minus 2x. So now we solve for x. We know that our equilibrium is 4. So then box off what I've done so far. 4 equals 0.7 minus 2x, the quantity squared, over, okay, and I'm going to be multiplying 0.2 plus x times 0.2 plus x. Since it's the same thing, I can say 0.2 plus x. Instead of times it by itself again, I can just say squared. Now, I can take the square root of everything. So, I get 2, square root of 4 is 2, equals the square root of the top is just 0.7 minus 2x. And the square root of the bottom is 0.2 plus x. Now I'm going to multiply both sides by the denominator, and I get 0.4 plus 2x equals 0.7 minus 2x. I'm going to add 2x to both sides to get 4x. If I add 2x to a negative 2x, I get 0. I'm going to subtract the 0.4 from both sides, so I get 0.3. I'm going to divide by 4 and get 0.075. So now, using this equation to find the equilibrium concentration of NO, I have 0.7 minus 2 times 0.075, and that's going to equal 0.55. So that is my final answer. Okay. So what did I do in summary? I first found the equilibrium constant. Second, I set up an ice table. Okay, and in the ice table, I used the concentrations that I'm told for equilibrium and the starting concentration for what was changed. Okay, this is I think the tricky part. Then I'm going to use stoichiometry to figure out how much of each one gets changed. Okay, don't forget that it's x, x, and minus 2x. Why minus? Because it's going to the reactions moving towards the reactants on the left. And then I use my new concentrations to find combined with my constant to find x. Okay, and then finally I plug it back into the equilibrium concentration to find what NO is at equilibrium.